Hey guys, hope you're doing well. So we're going to look at vectors and scalars in this lesson. And I'm going to start by just giving you a brief overview of what a vector and a scalar, what they are. And then we're going to go more into the vectors, and I'm going to show you how to draw vectors and how to calculate resultant vectors. All of that will be coming up. So all that you need to know right now so far is that scalars only have magnitude, whereas vectors have magnitude and direction. Okay, if you've got that up till now, you good, my bro. So let's quickly move on now to the more important stuff, like how to draw a vector. Okay, we'll start with scalars. Okay, so scalars are things that only have size. Okay, so only have... But now, instead of saying size, what your teacher will probably call it is magnitude. Magnitude. Okay? So that'll be something like, if someone asks you, hey dude, what's the time? Then you're usually going to say, it's 8:30, for example. But you're not going to say, hey bro, it's 8:30 south. You're not going to give a direction. Okay? Or if someone says, hey man, I see you getting quite strong at the gym. How much do you bench, bro? And the guy's like, oh, yeah, I bench 70 kilograms, bro. The guy's not going to say 70 kilograms to the right or 70 kilograms to the left or 70 kilograms north. You're only going to give the size, okay? So we mentioned time. We mentioned mass. Let's think of some others. So if someone says, hey bro, what's the temperature today? They're going to be like 27. They're not going to say 27 to the left. No, they're just going to say 27. So things like temperature, that only has size. Okay? So other things that you need to know for pretty much grade 10, 11, 12 for scalars is going to be time. Distance is another one. Like if you tell someone, hey man, how far did you walk today? They're going to say 3 kilometers, but you're not going to necessarily say 3 kilometers to the right or 3 kilometers to the left. With distance, it's just, you just give the actual magnitude or the size, the value. Speed is another one. Hey bro, how fast did you run today? Oh yeah, 20 kilometers per hour, bro. So that's just 20 kilometers per hour, but you're not going to say 20 kilometers per hour north, okay? It would be a bit weird. And then we already spoke about mass, and then energy is just one that will pop up every now and then. So scalars only have size or magnitude, but they don't also have direction. Okay, that's pretty much it for scalars. Now, if we look at vectors, vectors have magnitude, which is like size, as we said, but then they also have direction. Okay, so for example, some of the vectors that we talk about in high school are these ones over here. Now, some of these words might not be that familiar to you, but as we go through this chapter and we progress, they're going to start becoming more familiar. Okay, so I'm not going to get too much into what each of these are because, as I said, we're going to get into them more. But for example, force. Okay, force is measured in newtons. Now, if you're busy doing physics or whatever, and you say that the answer is 5 newtons, we never just leave the answer like that, unless they said only calculate the magnitude. But if they don't, then what we normally do is we say 5 newtons to the right, for example, or we'll say 3 newtons down. So you see how we've got the magnitude, which is how much, like the size of it, and then we also have the direction after that. Okay, now weight. Now this is a big one that confuses many people in normal everyday life. We get 2 things in real life. We get mass and we get weight. Now people talk about this one as if it's the same as this one. Okay, but mass is the one that you use like kilograms. So if you say, what's your mass? You would say 60 kilograms or 75 kilograms or whatever. But weight is actually not in kilograms. Weight is actually measured in newtons. So weight is actually a type of force. And so when you give your weight, you would say 700 newtons, and then you would say down, or 700 newtons, whatever. Okay? So it always has a direction. So mass and weight are not the same thing. But in everyday life, people talk about weight and mass as if they are the same thing. Okay, I'm not going to go too much into the details of that. That's not that important right now. And then acceleration we will get into, velocity we'll get into, and displacement we'll get into. So whenever you have one of these things, then always make sure that you always give the size and the direction. Unless the question only says, so let's make a little note here. If question only asks for magnitude, then no direction is necessary. Now, preferably, I mean, I don't have a ruler with me right now, but preferably you will use a ruler. Trust, you need to use a ruler. Otherwise they're not going to mark you correct. So you would use a ruler and you would just draw. So remember, a vector has size. So the size we can show by how long we draw our line, and then the direction we can show using an arrow. So for example, like that, for example. Okay. So you see how this would be going to the right hand side. If we draw a vector going like that, then that would be going down. It's pretty straightforward. That would be going left, and that would be going up. So for example, the length of the line tells us how big it is, and then the arrow direction tells us the direction. Okay. Now what you'll notice is that your teacher might mention that we need to show the length or the size using the length, but then they start getting rid of that. And as you'll start seeing when we're getting, especially into grade 11 and 12, we don't really start drawing the size anymore. Okay, but you'll see what your teacher says. So it is important that the length shows the size, but you'll see that your teachers are probably going to drop that after a few days. Maybe they won't, maybe they will, but usually they don't really take that into account. What they rather start asking you to do is just to put the number on the top. So if this is a 3 Newton vector, then you put 3 newtons over there. Or if this is a 4 Newton vector, then you put it there. Or maybe this is displacement, which is measured in meters, so you'd put it over there, for example. Okay, but as you go through class, you'll see what your teachers ask you to do. For now, that's not that important. Just see what your teacher says. Now let's move on. Okay, now something that they're going to ask you to do is they're going to ask you to work out the result of multiple vectors. Okay, so let's say, for example, we have 3 different vectors. Okay, so let's say we have let's say we're doing displacement, which is measured in meters. So let's say we've got, let's use force. Force is more popular. So let's say we've got a 3 Newton going to the right, then we've got another 2 Newton going to the right, and then we've got another, let's say 8 Newton going to the left. Okay, so let's just see that we've got a 3 Newton going to the right. Now I should be using a ruler, but I just don't have one with me right now. And then let's say you've got this random 2 Newton over here, and then you've got a random 8 Newton going to the left over here. Okay, and I'd be doing that with a ruler. Now, the way that you can work out what the overall result of all of this would be is choose one of them. Which one would you like to choose? Okay, I'm going to assume that you chose this one. Okay, so you're going to take that one, and you're going to take your ruler, and you're going to need to make a scale. So maybe you could say 1 centimeter on your ruler is going to be the same as 1 Newton. Okay, so 1 centimeter is the same as 1 Newton. So this is called your scale. So what you'll do is you'll take your ruler, and you will draw a 3 centimeter line. 3 centimeter line. Okay? I decided to go buy myself a ruler quickly, guys. I just took a quick walk down to the shop. So you'd do 3 centimeters, okay? So it would be starting over there, and you'd go 3 centimeters like that, and then you can just draw your little arrowhead. Okay, so we've done the first one. Now you can choose what would you like to do next. Let's do this one. Okay, so what you do, something I forgot to mention, very important. This is called the head. The arrow part is called the head, and this is called the tail. Okay, so this is the tail, and this is the head. So what you're going to do now is you're going to connect the next one's the next one's tail. Oh, you'll see what I mean now. So you, pretty much just what I'm trying to say is go to this one's head, and then just start the next one there. Okay, so you're going to take this one now, and you're just going to start that one. So that one's 2 centimeters. That'll go all the way up to 5 to there. You could have reset your ruler if you wanted to, and you could have put the 0 of the ruler here again. It doesn't really matter. So that's this one. So you see how I connected the head of the previous one to the tail of the new one. Now you're going to do the same with this one, but now this one is going to the left. So we're going to go from here now, which is the head, and we're going to go 8 to the left. Now, I'm not able to move my ruler around as much as I would normally want to, so I just had to do it in a bit of a weird way. But all that you want to do is you want to start over here, and you want to draw an 8 centimeter line going that way. Okay, so I just put it like that so I can go all the way to here. But you could obviously position your ruler in your own way, but you're going to draw an 8 centimeter line going like that. Okay, so now we have constructed all of the, or let's just put here what we did. So step 1, we plotted all vectors, and we used head to tail. So what that means is that the head, which is the arrow part, connected to the tail of the next one. So we connected all of the heads to the tails. Okay, now step 2, we need to work out the result. Now what is the result? So step 2, get the result. Now the way that you get the result is the following. So let's say here, how do we get the result? You are going to go back to the very start, the tail of the first one. Okay, so where did we start? We started over here. Okay, that's where we started, remember? Then I want you to go to the very end. Where did we end? Over here. Okay, so we went to the very start, which was the tail of the first one, and we went to the very end, which was the head of the last one. And then I want you to connect from the tail to the head. Okay, so from the tail to the head. So that'll go in this direction. Whoops, like that. That blue one that I've just drawn is the result. It's called the resultant. So, and we might need to, I'll give you another practice example after this one, because I know it might be a bit weird at the moment. But what we now see is that the resultant is 3 centimeters. Can you see that? It's 3 centimeters long. So we can say that the resultant is 3 centimeters going to the left. Okay, but now we know that our scale is 1 centimeter is the same as 1 Newton. So we can say that that is actually 3 newtons, because they're the same, and then we can say left. So that is your resultant vector, 3 newtons to the left. So what this actually means is that if you have a 3 Newton vector going to the right, and another 2 Newton going to the 2 Newton going to the right, and then you have an 8 Newton going to the left, if you combine all of that, then what will happen is that the overall effect is that it'll go to the left. So for example, if we had a box, let's say there's a box. Okay, this is a box on a table. Okay, and if we have a 3 Newton and a 2 Newton going to the right, so a 3 Newton and a 2 Newton, and then you have an 8 Newton going to the left, then the box will actually end up going to the left hand side, because we can see that this was going, well, these two are going to the right, but then this one is going to the left. And when we looked at what is the overall result of all of that, what we saw was that it's going to the left. And it makes sense. What is 3 plus 2? Well, 3 plus 2 is 5. And then so you've got 5 going to the right, and you've got 8 going to the left. So the overall effect is going to be 3 going to the left. Okay, but let's do another example. I know it might be a little bit weird still. And you see how I'm saying method 1? Because we're also going to be looking at a second method where we're going to rather use a calculation. And then I'm going to give you some more examples where we're going to use both methods. Okay, so we still have some interesting things coming up. So let's just do another drawing example. So let's say we've got 7 newtons up. And then, oh no, let's make the numbers a bit bigger. Let's say we've got 15 newtons up, 30 newtons down, and 25 newtons up. Okay, now you need to find the result. So we need a ruler. But now we have a problem. Not really, I'll show you how to solve it, but can you see that 15, I mean, that would work if we chose 1 to 1, but how would 30 work? 30 wouldn't really work, right? And so this is where we use a scale. Okay, so what we could say is that 1 centimeter on our ruler is going to be 5 newtons, because then this one will only be 3 centimeters, which our ruler can do. This one will be 6 centimeters, and this one will be 5 centimeters. You can choose a different scale if you want to. Just choose something that uses most of your ruler. Don't use something that only uses this little piece down here, and don't use a scale that goes too far off your ruler. The best is that you use most of the ruler, because then your diagram will be nice and big, but not too big that it can't fit on the ruler, if that makes sense. Okay, so this is vector number 1, vector number 2, vector number 3. You can choose whichever one you would like to choose first. By the way, I did not mention that in the previous example. You can choose whichever vector you want to choose first. The diagram might look a little bit different, but your final answer will be the same. So maybe your friend does it in a different order to you. So maybe if you're doing this with some friends right now, maybe one of you can start with this one and the other one can start with that one. And if you're super popular and you've got 2 friends with you, then there's 3 of you in total, and then the other one could choose that one over there. Okay, that was a stupid joke. And your diagrams will look a little bit different, but your final answer will be the same. Okay, so I'm going to start with this first one. It says 15 newtons, but we said that from our scale, then that's going to be 3 centimeters. So we're going to go, I'm going to start down here at the bottom, and we're going to go 3 centimeters up. Okay, boom, 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 boom. Obviously, I do have a ruler, but you understand, right? This is like in my screen, so I can't really use it like a normal ruler. Okay, but yours would look beautiful. And then there you put a little arrowhead. Okay, so we've done the first one. Now I'm going to be different, and I'm going to go do this one. And I'm doing that because if this one goes down, then it's going to go off my screen. So you can do that, and you could use that to your advantage. So I'm going to now do this one. You can do it in any order as long as you do all of them. So this one is going to be 5 centimeters up. And so I'll just go from here. Now you could take your ruler and you could put the 0 over here again and then just go up to 5. But I can't really move my ruler right now, so I'm just going to go up to 8. That should make sense to you, because 3 plus 5 is 8. Okay, so I'm there now. So we've done that one. And then I'm going to do this one, which is now 6 centimeters down. So what I do is I go to the head of the last one and I start there. But because so I'm just going to go there, and then I'm going to go 6 down. So that'll take me to the 2 over there. Okay, so that one's now complete. So how do I work out the result? Because now we've gone and we've put all the vectors. Now, how do I get the result? Well, what I do is I go to the very starting position, which was over here, and I go to the very end position, which was the head that I did over here. So that's going to be there. Okay. Now, some learners get confused. They're like, Kevin, must I now connect an arrow from there to there, or must it go from there to there? It must go from the starting one to the ending one. Okay, from the starting one to the ending one. So that's going to go there. So that one there is the result, or we call it the resultant. Okay, now if you look at the length, it's 2 centimeters. Now that's not your answer. You don't just say 2 centimeters. No, all of these are given in newtons. So what you're going to say is that the resultant is 2. Now that's measured in centimeters. So we're going to say 2 centimeters up. And then now we need to convert it. So we know that 1 centimeter is the same as 5 newtons. So then we're going to multiply this by 5, and so the result is going to be 10 newtons up. And there's your answer. You want to give your answer using newtons because that's what they started with. Okay? Now this 10 newtons up should make sense. If you have a box, and let's say there's a 15 going up, and there's a 25 going up, and then there's a 30 going down. Now, if you add these two together, that's 40. So you've got 40 going up, and you've got 30 going down. So what is 40? Take away 30. Well, that gives you 10. But we're going to get more into the calculations now in the next part. So what I just showed you in the previous slides was how to calculate the result using drawings. Okay, so we used a ruler and we used a scale. Okay, that's something that you do need to know now in grade 10. But then we also need to know calculation, and this one's going to become more popular, especially in grade 11. Okay, so let's say, for example, we've got 3 vectors again. So we've got 3 newtons going to the right, 7 newtons going to the right, and 6 newtons going to the left. So what you need to do, step one, choose a direction as positive. Now this is your choice. You can choose all of the rights to be positive, or you can choose all of the lefts to be positive. So most learners like to choose right going positive. So the way that you'll show this to your teachers, you'll say that all of the arrows going to the right are going to be positive. So what you'll then do, so we don't need a ruler for this one. This is not a ruler method. Now it's just a calculation method. All you're going to do now is you're just going to say 3 plus, or you're just going to plus all of them together. Okay, but all of those that are going to the right are going to be positive. So 3 and 7. But this one is going to the left. So that's going to go, because that's going to the left, you're going to say minus 6. Okay, and then you're just going to go add this all up. So 3 plus 7 is 10. This becomes a minus. So 10 minus 6 is 4, and you got 4 newtons. Now, can you see that your answer was a positive number? And you said everything going to the right is a positive number. So you're going to say to the right. You see how we're giving the magnitude and the direction? Because force, as we learned in the beginning of this lesson, is a vector. Okay, now, that's the first way you could have done this. I want to now redo the question, but what if I chose left as positive? Because maybe your friend chose left as positive. So how would that calculation look? Well, you would still add all of the things together, okay? But everything going to the left will be positive, but everything going to the right will be negative. So it would look like that. Now, if you had to go calculate this, you're going to end up with negative 4 newtons. Now, here's where you need to make you need to change it at the end. You chose everything going to the left as positive, but you just got a negative answer. So left is positive, so negative means right. So in the next line, you're going to say that the answer will be 4 newtons to the right. Okay, you see how we get the same answer? So your friend might have chosen to the right as positive, and you might have chosen to the left as positive. That is completely your choice. There's no right way to do that. Right way, I just got that now. Funny joke. But there's no right or wrong way to do that. But make sure that when you give your final answer, it's positive. You see here, positive, and you see here, positive. I didn't leave it as a negative. I changed it back to a positive answer. Okay. Now, for the rest of this lesson, we're just going to practice this, okay? So here's our first practice question. It says, work out the result using both methods. Okay, so that's the calculation method as well as the drawing method. So let's just divide our page into 2, and let's use, number 1, we'll use the drawing method over here. You do need to know both, okay? And then calculation method. So for the drawing method, you need a ruler and you need to give a scale. So if you look at these ones, it's going 3 to the right and 4 to the right. So I think a scale of 1 centimeter to 1 Newton, that'll work nicely. So you can start with whichever one you want. I'm going to start with this top one, 3 newtons to the right. So I start over here and I go 3 newtons to the right. Okay, now that is the head. So for the next one, you join it, or for the next one, you start it where this one ended. So we've done that one. So now we start over here and we do 4 newtons. That'll take us all the way up to 7. But if you wanted to lift your ruler up and start over here at 0 again and then just go up to 4, That's way better. I just can't do that right now because it's like stuck on my computer screen. I can't move it very easily. So I hope you can understand why I'm doing that. And so there we've drawn both the vectors. Now to find the result, you go right to the beginning, which is this part, and you go right to the very end, which is that part, and you connect from the beginning to the end. So from there to there. That black arrow that I've drawn, that is the result. We call it the resultant. Okay, so let's see, it's 7 centimeters. So the resultant is 7 centimeters. So if you look at your scale, that means the answer will be 7 newtons. And then you need to give a direction. Look at the direction of that black arrow. It's going to the right. You have to give the size or the magnitude and the direction. Okay, now when we use the calculation method, you need to choose either right as positive or left as positive. If it was up and down, then you would either choose up as positive or down as positive. So I'm going to choose going to the right as positive. Then I add both of them together, but they're both going to be positive numbers because they're both going to the right. So you're just going to do it like that. And if you calculate that, that'll give you 7 newtons. And it's a positive answer. And you chose right as positive. So you're just going to say to the right. So we're going to do this example now. And then I've got this example. Okay, so just 2 more examples. This one and then this one. Okay, so here we're going to work out the result using both methods again. So we will do the, I'm going to do the ruler method first, or the drawing method first. So let's just do drawing. Okay, so we need a ruler. And now you need to know your north, south, east, and west because many times they will do that. So north, west, south, east. Okay, in that direction, that direction, that direction, and that direction. So the first one says 3, then 6, and then 4. So if you look at these numbers, yeah, I think it'll be nice if we, a good scale would be 1 centimeter is the same as 1 newton. That'll work nicely. So the first one is 3 newtons east. So it's actually just to the right. So we start over here and we go 3 to the right. There we go. Now you can do whichever one you want to do next. I don't want to do this one because if I do 6 west, it's going to go off my page. If I go from here, it's going to go off my page. So you got to be a little bit like wise with your decisions about that. So I'm not going to do this one just yet. I'm going to do, but this one also isn't going to work. Ah, man. Okay, this one could actually work. Let me just move my ruler a little bit. Okay, so you see how I just moved my ruler a little bit to the left, but you could obviously pick your ruler up and then just place it on your page again, okay? But I don't have that option right now. So I just need to, I moved it. The 0 was over here, but now I just moved it so that the 0 is over here so that I can draw a 4 centimeter line. Oh, but that's not going to work, Kevin, because then you've got this 6 going to the left. Oh, man. Okay, so what you do in a situation like this is you restart. So what I noticed is that the drawing seems like it's going to go more towards this side. So it's more towards the left-hand side. So I need to be on this part of the page, on this side of the page, so that when it goes to the left, everything can fit in, okay? So there, I decided I'll actually just turn my ruler upside down, but obviously you guys can use it in the normal way, but because I'm doing this on a computer, it's a bit difficult. Okay, so I'm going to start with this one. I'm going to start with that one over there. So that's going to be 6 newtons. So I'm going to start over here, and it's going to the west. So it's going to the left side. So I'm going to go all the way to 6 newtons, which is there. And then I'm going to put the little arrowhead. Okay, that one's done. Then I'm going to do this one, which is then another 4 newtons to the west. So I'm going to start over here, and I'm going to go 4 newtons to the left. So 4. Good, that was a little bit too far. So there. Okay, so that one's now done. And then this one goes 3 to the right. So you go to the ending position, and then you go 3 to the right. So that'll go to there. Now, the resultant is when you go from the very beginning to the very end. And you draw a line from the beginning to the end. So that's going to be from here to there. So what we can see is that the final answer is this one that's in black, and that is 7 centimeters. Can you see it goes all the way up to the 7? So that's going to be 7 centimeters. So we can say 7 centimeters, and that is going to the left. So we'll say west. So we can say west, and then we need to convert back. So remember, 1 centimeter is the same as 1 Newton. So we're going to say that the resultant is going to be 7 newtons west, like that. Now we're going to do this question using the calculation method, and then we just have one more example over here, and then we will be done with this lesson. So if you've made it this far, you are awesome. Well done for putting in the effort. So let's just remember our answer. We said 7 newtons west. So we should get the same answer when we use the calculation method. So for the calculation method, you need to choose what you want as positive. So you can choose west or east as positive. I'm going to just choose east as positive. So then we've got 3 vectors that we're going to add together like that. Now this is, we said to the right is, or to the east is positive. So this 3 is going to be a positive number. The 6 is going to be a negative, and the 4 is going to be a negative, like that. And then if you had to go calculate this, you end up with -7. So what does that mean? Well, we chose everything to the right, or everything east is positive, but then we get a negative answer. So all that means is we're going to say 7 newtons, and we're going to say west. Because if east is positive, but we're getting a negative answer, so east is positive, west is negative. So we got 7 newtons west. You see, it's the same answer when you do as when we do the calculation or the drawing method. Here's our last example. So we're going to use the 2 methods once again. So let's start with the drawing. And so what we should observe is that these numbers are too big for this ruler. Okay, now your ruler might be bigger, so then you would be fine. You could just say 1 centimeter is 1 Newton. But because my ruler is a little bit smaller, what I'll do is my scale will be like this. And you and your friends can choose different scales, but your final answer will be the same. That's the awesome part. So I'm going to say that 1 centimeter is the same as 2 newtons, because then 8 newtons will be 4 centimeters. This will be 10 centimeters. This will be 1 centimeter, and this will be 9 centimeters. Okay, and so I'm going to start over here, and I'm going to do this as number 1, then I'm going to do this as number 2, then I'm going to do this as number 3, and I'll do this one as number 4. Okay, so we're going to start here, and we're going to go 9 centimeters. Okay, so 9 centimeters, whoops, so up to there. Obviously, you guys would do it nicely with a ruler. Okay, so there's 9 centimeters, and so that's vector number 1 complete. Then I'm going to do this one next. So this one's 1 centimeter, also going to the right-hand side, so just 1 centimeter, like that. Then I'm going to do this one, so that's going to be 4 centimeters, but now it's going to the left. So I go to the ending position, which was over here, and then I go 4 to the left, up to there. And then my last vector, I need to go 10 centimeters to the left, but now you'll see that I don't have enough space. Okay, so I'm just going to move my ruler to over there, because then I can just go from the 10, over here, and I can go 10 centimeters. But obviously you can position your ruler however you need to, as long as you can get a 10 centimeter line like that. Now to work out the result, you go from the beginning, which is this one, and you draw a line to the end, which is that one. So you're going to go from there to there. So that's 4 centimeters to the left. So we can say 4 centimeters left. But now we mustn't give our answer in centimeters. We must give our answer in newtons. So we know that 1 centimeter is the same as 2 newtons. So 4 centimeters would be 8 newtons. So we're going to say 8 newtons to the left. Now let's quickly do the calculation method, and then we're done. And as I said, your friends might have chosen a different scale to you in the beginning, but your final answers will be the same. So with the calculation method, you need to choose a direction as positive. I'm going to choose all the things going to the right as positive. Then we've got 4 different numbers that we're going to be adding together. Okay, so these two, they're going to the right, so they will be positive. And then these two, they're going to the left, so they will be negative. Okay, and so if you had to add this up, you end up with -8. So what that means is that if you're choosing everything to the right as positive, then everything to the left is negative. So if you got a negative answer, that means left. So you're going to say 8 newtons left. And that's exactly the same answer we got when we did the drawing method.